Hello, in this video we're going to talk about functions, right? First we know what is a function. A function is just going to be any correspondence between a set of independent variables, which we designate x, and a set of dependent variables, which we designate y, and such that each x corresponds to unique y. A lot of times what we'll do is we'll call the set of x our inputs, we'll call that the domain, and instead of y, our outputs, we'll call the range. One thing we might want to know is how can we tell if we have a function? First, we could solve for it algebraically if we have a function in terms of y is equal to f of x, right? If we have to get a plus and minus, then we know we don't have a function. If we have graphically, it's what we call the vertical line test. And that's if any vertical line drawn on a graph passes through the function in at least 2 points, right? Then we can say we do not have a function. One thing we might want to know is we talked about the domain. The domain is the allowable input values. So in this case, the allowable x values. So we want to say here, what are the values of x that will produce the real values of y? Or another way to say this is, what is the domain? The domain. And so what we can do is we can look at this square root of x minus 3 and say, are there any bad values? Are there any values that will give us a false conclusion? And of course, we know that anything in a square root has to be positive, right? I can't take the square root of something like -2. So what we want for the domain is we want that x minus 3 to be greater than or equal to 0. We can solve that, and we get x greater than 3, and we can write that in our interval notation, right? And this would be the domain of our function y is equal to the square root of x minus 3. One thing we want to talk about is what this notation means, right? Typically when we have a function, we write y is equal to f of x, right? And that's just to signify that y is a function of x. But I think one of the problems is people give too much power to x, right? One thing we want to read is when we read this y is equal to 2x plus 1, for example, we might write f of x is equal to 2x plus 1, right? We want to read that as f of x, never f times x, right? It's never f times x. And what we want to think about is a function always needs an input, right? Every time a function needs an input. So if we are talking about a function x, we need a function f of x. This value we're going to put in, right? We might have f of 2 or f of -5, right? Those are things we might want to compute when we deal with functions. And again, when we plug values in for functions, it's really important, right? Like we said, x is given too much power, but really what we want to think about is that x is really just a placeholder. F of x equaling x cubed plus 2x plus 1 can really be thought of like f of blank is equal to blank squared plus 2 blank plus 1. Right? Whatever gets plugged into this left side blank is going to get plugged in every spot I see a blank. So for example, cite f of 5, of course we mean 5 cubed plus 2 times 5 plus 1, which is 125 plus 10 plus 1, or 136. Right? That's exactly what we say here, right? If I have f of x equaling x squared plus 2x plus 1 over x, then f of 2 would plug a 2 in everywhere there's an x. So we'd get 2 squared plus 2 times 2 plus 1 over 2, right? Which would be 4 plus 4 plus 1/2, which would be 8 plus 1/2, which would be 17 over 2. That applies to anything. So if we want to evaluate something like f of a plus b, then what we're going to do is plug the entire quantity a plus b everywhere there's an x, right? With parentheses around it. So what we would actually get is f of a plus b is the quantity a plus b squared plus 2 times the quantity a plus b plus 1 over the quantity a plus b. Right, that's a very important thing as we move forward, and we want to make sure we get that. All right, let's do 2 quick examples of this to demonstrate this. We want to find f of 4. If f of x is equal to x plus 2 divided by 9 minus x squared. So of course, based on what we just talked about, we'd replace every instance of x with our 4. 4 plus 2 divided by 9 minus 4 squared, which would be 6 over 9 minus 16, which is 6 over negative 7, or negative 6/7. Right? Here I'm going to do f of x plus h. And again, it really doesn't matter if I'm plugging 4 in for x, or I plug x plus h in for x. I really just take the entire quantity and plug it in for x everywhere I see an x. So this would just be the quantity x plus h plus 2 divided by 9 minus the quantity x plus h squared. Right? And if we wanted to expand that a little, that top parentheses is unnecessary, so we can just write that. 9 minus, again, we can't just distribute because I have that plus, so we're going to have to FOIL plus 2xh plus h squared, right? And to finish this off, we'll distribute this negative, so I get x plus h plus 2 divided by 9 minus x squared minus 2xh minus h squared. And that would be our final answer. All right, here's the definition that will be important moving forward. It's this idea of a difference quotient. So for any function f of x, we can call the difference quotient an expression f of x plus h minus f of x divided by h. Right? It's just that expression. And it turns out the difference quotient is really important because it helps us find, in Calc 1, it helps us find the derivative. So it's worth introducing here. And so questions we might want to solve for this are like the following. Just simplify the difference quotient for a function f of x is equal to 3x squared. So the difference quotient is f of x plus h minus f of x divided by h. And so what we're going to do is replace f of x plus h with its appropriate f of x value. And again, this x plus h is going to replace the instance of x there. So I'll get 3x plus h quantity squared. Right? Here, I want this f of x, so minus 3x squared. And lastly, I get this h divided by h. Okay? And so what we want to do is just simplify this. Right? We'll move this down here. And so I'll say, what can I do to simplify this? The first thing I'll have to do is expand, right? I can't distribute that x, that squared between x and h. I have to FOIL minus 3x squared divided by h. Right? I can distribute this 6xh plus 3h squared minus 3x squared all over h. Right? I know it's really tempting to want to cancel h's, but we can't just yet. Right? The only way we can cancel is if we factor. And so far we haven't factored, so we can't cancel. So let's see. I can see my 3x squareds cancel because they're just plus and minus. So I get 6xh plus 3h squared divided by h. Right? I can cancel an h, but first I'm going to have to factor one h out of the top. Right? I can't cancel until I factor. Right? I factored out an h, I can cancel, and my final answer is going to be 6x plus 3h. Okay? Hopefully this was helpful, and I will see you all in class.